Module 11 will show you how to test the parametric assumptions using SPSS. So many statistical procedures we use are based on parametric data and have parametric assumptions. Assumptions for parametric statistics include normally distributed data, homogeneity of variance, and we also need to make sure that there is independence within the data. Before embarking on any statistical tests, data should be cleaned, checked, and screened for normality. You should already have the skills to clean and check your data from previous modules. Review of your data is often performed by running descriptive statistics. By using the Explore option in descriptive statistics, you can also run the necessary normality checks of your continuous variables. So to do this, we have a look first at our variable view, and we can see through these being scale variables, height through to weight, we are going to assess for normality. We come up to Analyze, come down to Descriptive Statistics, and we come across to Explore. We now need to select the continuous variables and move these across to the dependent list. So you can see here we have our first height. If you scroll down and hold the Shift key, we can select height all the way down through to weight, which will be a total of 8 variables. And then we use the arrow to bring it across to our dependent list. We then select the Statistics tab, and then we ensure that the default descriptors is selected and click Continue. Now come down to the second button and click Plots. And for this one, we want to say no box plots. We want a histogram instead of a stem and leaf. And we're going to ask for normality plots with tests. Once this is selected, click Continue. We also have the buttons Options and Bootstrap, but for this example, we won't be using this today. The bottom left-hand side will show you your display, and because we want both the statistics and the plots to be provided, we can click both. Once we've done this, we're going to come across and click OK, and the following output screen should become displayed. The first part with the writing will tell you what we've actually asked SPSS to do, and you can now see the data has opened. The first section that you see is the case processing summary. This tells you how many are available for each of these variables. So as you can see, we actually have 14 available. However, there appears to be one missing. So in total, we should actually have 15 pieces of valid data. Because this is missing, we actually want to go back and we actually need to have a look at these. And we can actually choose under that Options tab something a little bit different to make sure that we will actually have all these variables included. So this button here actually will allow us to recall our most recently used functions. So instead of going back up to Analyze and going through the full process again, we can actually click this drop down. We can see all the last things that we've done, and we can click Explore. Now this Options tab has a few different ways to help us treat our missing values. The first, Exclude Cases listwise, tells us about the cases with missing values for any dependent or factor variable, and then excludes them from all analyses. So therefore, if there's one variable missing for any of those, so one piece of data missing for any of those variables, it will be excluded. And this is what's happened in this instance. Exclude cases pairwise, as long as the variable you requested does not have any missing data points, it will be included. So in this case, let's actually select this button, click continue, and then we can just run it again. And we can now see that for birth height in meters, all the way down to age 3, we now have a full 15 sample data set. For age 1 to age 3, we also have 15, and it's just that birth weight in kilograms that was actually missing one piece of data. So when you do a visual check of your data, this should actually correspond with a missing value. So let's jump back into data view, move our output screen out the way. And when we have a look, we can actually see that ID 4, yes, there is a missing value here. So a visual check is a really easy way with such a small sample. However, once we get a large sample, it can be quite difficult to see these missing values. If this was a real life scenario, we'd have to go and look up the weight, and if it wasn't there, we would have to leave it as missing. But in this instance, we know that the weight that was missing is actually 3.699. So please enter that under weight for ID number 4. With our output, it doesn't automatically update our output when we adjust any of these values. So what we need to do is now we need to rerun it again. So we can come down to the drop-down menu, explore, click OK. And what you'll now see by the case processing summary is we now have valid 15 sample per variable. You may have noticed in our visual check that there was another variable that did look a little bit funny. So one way we can assess this is we can actually see if there are any extreme variables. Looking at our birth height in meters, we can see the mean of the birth height in meters was 5 meters. Now this doesn't sound quite right. When we come down and have a look at the minimum, 0.49 meters, that makes sense. The maximum actually says 69 meters. So that is not a plausible value for a human for their birth height. If we remember jumping back to our data view, if we have a visual check, sure enough, there appears to be a value that does look quite out of place there. Now, if you had a large data set and you weren't too sure where this variable was, there is actually another way of having a look to see about these extreme values. So let's come back up to the Recall tab and come down to Explore. We're now going to remove all these variables except for birth height in meters. So left click on age 1, scroll down, hold shift down and click down to age 3, and then use the arrow to return it. You could also press the reset button, but by doing that, you'll have to go back through statistics, plots, and options and re-put in all your selections. So you can see in our dependent list, we just have our birth height in meters remaining. Under the statistics box, we can now select the button Outliers. So this is going to identify any outliers in our case, so any extreme values. Click continue. Under the main display here, we're going to click just asking for statistics. So we don't want all the rest of the stuff that normally comes up. And we then click OK. So we have our little output summary here, which is telling us what we've asked SPSS to do. You can see from our case processing summary that we have 15 in our sample for birth height in meters. When we have a look at our descriptives, once again, mean is still remaining at 5 meters with a minimum of 0.49 and a maximum of 69 meters. But now we get this new table called extreme values, and it will tell you what are some of the top 5 highest and the top 5 lowest values, and it will actually identify what their case number is, which is very handy when you have a large data set. As you can see here, case number 6 actually has a value of 69. So this is a really handy way to screen your data, especially if you do have a large sample and sometimes run the risk of a visual assessment not picking up everything. So we can assume that this is probably a typo. However, we cannot just change this value based on an assumption. So first we must go back and check the original source, and then if it was provided correctly in the original source, we can edit appropriately. If the original source cannot be checked and the value is obviously an error, you will then need to delete the entry and consider it missing. Or if the value is not obviously an error, you'll actually need to leave the value and assume that this is true. In this case, we've gone back and checked the original source, and you can replace this data value for birth height in meters as 0.69. So we return to our data view screen, and where it says for case 6, 69, we'll replace this with 0.69. We can now rerun our normality check again. So come up to your recall, recently used dialogues, across to explore. We're going to add age down to age 3 back in the dependent list. Click both for the display. Under statistics, we can exclude outliers, so we just want descriptives. Under plots, we've got normality, plots with tests, none, and histogram. And under options, we're going to exclude cases pairwise still. And click continue. We now click OK. We can see in our case processing summary, once again, there's still 15 in our sample per variable. And then we can have a look at this descriptives table. The critical values of interest is our mean, which here is 0.6293. Our standard deviation, which is 0.07. Our median, which is 0.66. And we can also see our 95% confidence intervals. We can also see our skewness and kurtosis. And for these two values, we want them to be as close to 1 as possible to indicate that our data is normally distributed. So we can go down and scan all the rest of the data. And then we come to our tests of normality table. So our tests of normality table, we use the Shapiro-Wilk, and this will give us a p-value, which we see under sig. And this will indicate which one of these variables, based on this test, is normally distributed. In these tests, we are looking for a p-value that is greater than 0.05, which means that there is no difference in your data's distribution compared to a normal distribution. In other words, greater than 0.05 means this variable is normally distributed. So coming down this column, we can see that birth height in meters is actually less than 0.05. Therefore, birth height in meters is not normally distributed. However, for all these other variables, we can see that they are normally distributed. Having a look at the tests of normality table and the skewness and kurtosis scores aren't the only way to do a check of normality. We can also have a look at the histogram And what we're expecting with the histogram is a nice bell-shaped curve, which you can see here does not look normal in the case of birth height in meters. So this example here further supports that birth height in meters is not normally distributed. However, if we'll compare it to height at time point 2, you can see that this does actually have a bit more of a bell-shaped curve. So that's another graphical proof that height at time point 2 is actually normally distributed. Let's scroll back up to birth height. And the other way we can actually have a look is having a look at our QQ plot. So this graphs the expected normal against the observed value. And with this line through the middle, we want our points to be sitting as close to this line as possible. The closer the points are to the line, we can make the assumption that the data is normally distributed. So in this case, quite a few of the points are coming off the line. And if we scroll down to one that is normally distributed, you can see these points are sitting a lot closer to the line. We review the p-value from the Shapiro-Wilk in the test of normality output. And we can also do a visual assessment, having a look at the histogram as well as the normal QQ plot.